Okay, so in this lesson for Math at Work 10, we are going to be looking at expanding our knowledge from just area to now looking at surface area. So what we've been doing so far is just been area of a two-dimensional shape. What we're going to be expanding to over the next couple of lessons is looking at the surface area of a three-dimensional shape. Okay, so today's lesson will focus on prisms and cubes, and then we'll have a separate lesson on cylinders and cones. All right, so let's get started. All right, so a few key terms with this one. So when we talk about surface area, we're talking about the number of square units. So the units for surface area will be similar to area with something squared. So it's the number of square units needed to completely cover a 3D object. So think about trying to wrap something up or cover something up, a present in paper. How much paper would you need in order to cover all of exactly the amount of the surface? Or trying to paint the outside of something, right? How much paint would you need to cover all of the area in that sense? Okay, so we'll be looking at three separate shapes. One is a cube. So if we define a cube, it's a three-dimensional object where all lengths are equal, and that results in 6 faces. So when we talk about a face, we're talking about a surface of the three-dimensional object, so something like you could actually place your hand on. And there's 6 faces in a cube, and each of those faces is an identical square. Right, so it's basically just a three-dimensional square. Okay, we'll also be looking at a rectangular prism, again a 3D object, also with 6 faces. However, not every single face is the same, but opposite faces are equal. Right, so the top would be the same as the bottom, the front would be the same as the back, and the sides would be the same as well. And they might be different rectangles with different dimensions, but the opposite sides are the same. Then we have a triangular prism, which is again a three-dimensional object. This one will only have 5 faces due to the fact that a triangle only has 3 sides. So if you took a triangle and then put rectangles on all of the sides, right, and then another triangle to kind of bookend it, right? So think about capping something with triangles, and then there would be 2 rectangles going down the slant sides and 1 on the bottom. Okay, so that's where you get your 5. So you'd have 3 rectangles and then 2 triangles. And some of the methods that we'll be taking a look at of how we would solve these problems would be actually trying to take a look at a net. Okay, so when we talk about a net, we're talking about a flat 2-dimensional representation of a 3D object. So thinking about having a 3-dimensional object where you can actually just pull each of the faces down and lay it down flat, and then you're kind of seeing each of the shapes, right? Each of the surfaces as just a flat area object, which you can then calculate the area of each one and add them all together, and that would give you your surface area. Okay, so again, here are the objects we're going to be looking at. So obviously this would be our cube, right? So you're seeing that each of the faces, right? So this would be a face, this would be a face, this would be a face. They're all the same. You can see 3 from this perspective, but again, there's 1 on the back, there, and then 1 on the bottom. Okay, this would be your rectangular prism, right? So again, you're seeing, this rectangle here and the one on the back would be the same. This top and this bottom would be the same, and then this side and then this side that you can't see over here, right? Sometimes these will be squares, sometimes they won't, right? So if these are squares, then all 4 of the rectangles will end up being the same, but that's not true for all cases. You have to look at the dimensions carefully, okay? With triangular prisms, you actually have a couple different ways of kind of picturing them, just because there's different ways to picture triangles, right? So in this case, what appears to be just an equilateral triangle where all 3 sides are equal, right? Where in order to calculate the area here, you've got the base along the bottom and then the vertical height going straight up, right? This length here is what we call the slant height. Okay, some of you might remember from grade 9, you can calculate that with Pythagorean theorem. I'm not going to ask you to do that in these lessons. I'm just going to give you those values. Pythagorean theorem is something we're going to focus on a little bit later, but not for the context of this, right? So anyway, going back to this, right, you can have this type of triangle here, right? And then these side lengths would be equal. So therefore, what you'd have is that this rectangle on the side and then this rectangle on this side would be the same, but then this rectangle on the bottom might be a little bit, well, actually, if this is an equilateral triangle, it's also the same, but if this is slightly different, then these opposite sides would be the same, but the bottom would be different, right? It depends on what these values are, okay? This one would be a right angle triangle, right? Where, again, you've got these bookends. Here's this triangle and then this triangle at the back, and then you've got 3 completely different triangles here, right? Where you've got 3 different rectangles, You got this big rectangle here that would have been 5 by 11. Then you've got this rectangle that's here along the side that would have had dimensions 3 by 11, and then the rectangle on the bottom is 4 by 11. All right, so again, just watch depending on the triangular prism, they're not all the same. It depends on what it's going to look like, right? So look at the diagram carefully or read the question carefully so you're drawing the right one. Okay, when I'm talking about a net, right, so again, this would be a net of the triangular prism. So think about taking these triangles and just kind of like ripping them off and laying them down flat, and that's what you get here. And then taking these rectangles and laying them down flat, that's what you get here, right? So these would be the side rectangles that you'd kind of fold up, and then these you'd fold together. You get your triangular prism, right? And this would be what your cube net would look like, right? You see the 1, 2, 3, 4, 5, 6 faces, and they're kind of showing you how that would kind of fold together, right? You just kind of, this would be the bottom, and then fold everything up, and this one over. Or this would be the net of this rectangular prism here, right? Where again, you're just kind of like taking the sides, like cutting along the edges and folding them down, right? So I mean, there's your 3x4 folds out, right? There's your 3x4 and your opposite 3x4 over there. They're folding out, and then everything else kind of folds down, right? One folding them this way, and then the other 1, 2, 3, 4 the other way. Okay, so that's what your net's going to look like. Okay, so we're going to be looking at two kind of ways to being able to solve and calculate surface area. One, the first method is to kind of draw the net of the object, right? Look at each of the faces, even if it's not the full net, but just like drawing each individual face and what would its dimension looks like, right? So if you're good at visualizations, that'll probably be pretty easy for you, just kind of unfolding it, or even just kind of going around the shape and drawing, okay, this is the triangle and this is the rectangle and these are the dimensions of each one, right? Then you just are using your area formulas that we've already been doing with triangles, and rectangles and squares for this lesson. Circles will be in the next lesson, right? And then adding those up. Now, the other method you can use is you can use a formula if one exists, okay? So there are some 3D objects that have a specific formula for finding the surface area. If it does have a formula, I will give it to you and I'll discuss it and we'll go through those examples. But if you are going to choose to use the formula, make sure you understand how it works, right? Because sometimes the formula is just more generic and it just says find the area of all the sides, right, which is not really helpful. Or sometimes you're using a formula, but it's then asking you to, you're not painting the bottom, so which part of the formula then has to get subtracted, and just thinking about it that way. Okay, so we'll do 3 examples and then I'll give you some work to try on your own. All right, so here's our first one. So a finished chest is to be painted on the outside, including the bottom. The chest has dimensions of 4 feet long, 1.5 feet high, and 2 feet wide. What is the total area to be painted? Okay, so in this case, go to the whiteboard, right? If I close the lid on that chest that I was just looking at, right, what I get is a shape that looks like this, right? Where it's 4 feet long, 1.5 feet tall, and 2 feet wide, okay? So if I'm thinking about trying to find the area or the surface area of this entire shape, what I would be doing is thinking about the net aspect of it, right, and what that would look like unfolded, okay? So I could try and visualize that and say, okay, well, if I fold this, almost square down, I'd kind of have this square that would look like this, right? Then I'd have this long rectangle in the middle, and then there'd be that other square on the end, right? And then you'd have other rectangles along the side, right? This one folding down, and then the top maybe attaching with it, right? So this is the top, this is a side, this is the bottom, right? And then this would be your other side on that one. Okay, so you could try and unfold it that way, or you can just kind of visualize it and think about it and say, okay, well, let's just start with trying to do it. Let's just talk about how would I calculate the area of the front and the back, right? Just kind of organize your work so you know what's what, right? So front, back. All right, well, that's just a rectangle with lengths, right, dimensions of 2 by 1.5, and there's going to be 2 of them because it's going to be the same on that side. So what I would do to find that surface area, or just the area here, it's not the surface area, the area is 2 times the 1.5 feet times 2 feet. Okay, because I'm just doing the length times width, 1.5 times 2, and then I'm doubling it after I get it because it's the front and the back are the same shape. So when I do that, it's basically saying, well, the area of just this is the 1.5 times 2, which is going to be 3 feet squared. But then this and this are the same, so I double it. So this area is actually 6 feet squared, right? So that's just the front and the back would be 6 feet squared, okay? So next, we would look at perhaps doing the top and the bottom, okay? So then if we do top and bottom, okay, so if we imagine the bottom, right, the bottom of the chest is 4 feet long. If I try to kind of do this dotted line to make it more three-dimensional, right, it's 2 by 4. And again, the top would be the same, this would be 2, and this would be 4. So again, there's 2 of them. So the answer I'm going to get, I'm going to multiply by 2, and the rectangle part is 2 feet times 4 feet. So I'd multiply the 2 by 4 and get 8, and then I double it because it's 1, and then it's the exact same one again. So 2 times the 8 feet squared, so that's going to be 16 feet squared. Okay, just erase this so I can do the sides. Okay, and then here for the sides, right? So I've done the front and the back here. I've interpreted this as the front, so this square and that square have been done. I've now done the bottom, I've done the top, so now what I'm trying to figure out is what is the area of this side, right? So sometimes it even helps to kind of draw it out and just kind of run your pencil over it and say, okay, well, what shape is that I just drew? It's a rectangle. What are the dimensions of it? Well, it goes 4 feet, and then going up is 1.5 feet. And again, that is the same as the one on the other side. So again, it's double the length of 4 times the width of 1.5, or base times height. So 4 feet times 1.5 feet. So I find that area. So 4 times 1.5 is 6. And then I double that. Okay, so I get 12 feet squared. So the front and the back are 6 feet squared. The top and the bottom are 16 feet squared. And the sides are 12 feet squared. So then what I would do is add them all up. Right, so the total surface area is going to equal the 6 plus the 16 plus the 12. And when you add that all up, you get 34 feet squared. And that's the total area that's going to be painted. Okay, so that's one way of being able to solve that problem. The other way of being able to solve that problem is through the use of a formula. Okay, rectangular prisms do have a formula that you can use, and it looks something like this. So the formula for the surface area of a rectangular prism goes like this. Surface area equals 2 times length times width plus 2 times length times height plus 2 times width times height. Okay, or some people might even see it as this, 2 outside of the big set of brackets, LW plus LH plus WH, right? You're just basically factoring out that 2. Okay, but I'm just going to leave it like this one, right? Because this one represents what we essentially just did, right? You did the length and the width, and then you doubled it, because it's 2 opposite sides are equal. You do the length and the height, and then, so you multiply those together, then you double it, because opposite sides were equal, and then you do the width and the height that you're multiplying together and double that because opposite sides are equal. So if we did that with this same chest, right, the length was 4 feet and the width was 2 feet. And then for this next part, 2 times the length, which was 4 feet, times the height, which was 1.5 feet. I'm just going to have to go down here, plus 2 times the width, which was 2 feet, times the height, which was 1.5 feet. And if we did each of these as a little section, right, 4 times 2 is 8, and 8 times 2 is 16, so that would be 16 feet squared. 4 times 1.5 is 6, and 6 times 2 is 12, plus 12 square feet. And then 2 times 1.5 is 3, and 3 times 2 is 6. And it might have happened in a different order, but it doesn't matter. When you're adding things, the order doesn't matter. So if we add the 16, the 12, and the 6, those are the same numbers we got using method 1, and we again get 34 feet squared. Okay, so that's that first one. Either method will work in getting you the surface area that you're looking for. Okay. So again, what I've done is I put the answers in here as well. So in this one, you can see I've drawn out the net and kind of colored it. It just might have not matched necessarily in what we just did. I think yeah, because I think what I interpreted here is sides. I used as front and back for my diagram. You get the same numbers no matter what, okay? And then here's your option 2, which the formula, it's all the same things. You just kind of, it's tidier in one neat little spot instead of having 4 different calculations going around the page. But both are 100% correct methods of doing this. Pick the way that you like the best, okay? All right, so moving on to example 2, we'll do an example with a triangular prism next, okay? So in this one, we're going to talk about a Toblerone chocolate bar. It's in the shape of a triangular prism, and it's being wrapped up for Christmas for Mrs. Keats. So this is a fact. I get one of these for Christmas every year. And here are the dimensions of the chocolate bar in the diagram shown, right? So you see that it is a triangular prism here. Its length is 6 centimeters long. Its base is 3 centimeters long. Its vertical height is 4 centimeters long. And this slanted height is 4.27 centimeters long, okay? So that's the dimensions that we're dealing with. And what we're being asked is what area of wrapping paper is required to cover the entire Toblerone bar, okay? So if we're going to put a piece of wrapping paper on every single one of the sides to cover it completely, how much of wrapping paper would we need, okay? So again, the first thing that I would do here, so I already have the diagram. I'm just going to redo it up on our board. Okay, so we essentially have the following. Right, so we know that this is a length of 6 centimeters. This right here was 4.27 centimeters. Along the bottom was 3 centimeters. And straight up and down here, that was 4 centimeters. So triangular prisms, because different triangles will make the prism look different and have, you know, different dimensions for how you do the rectangles and even how you do the triangles, there's no real set formula. So in this one, there's no real, oh, just take these numbers, plug it into this formula, and you get the answer. It's not going to work like that because every triangle is a little bit different. So instead, you really do need to kind of look at it in either the net form or just kind of visualizing and thinking about it going, okay, let's start with the triangle. There's going to be one on the front and one on the back, right? So this triangle and this triangle is same. So if we talk about the triangles part, we know that the area of a triangle is base times height divided by 2. But because these are the exact same, once I get the area of one, I'll just times it by 2, right, double it to get the second one. So remember with triangles, the height has to be perpendicular, so it would meet at a right angle, so it's going straight up to the top, so that's the 4 centimeters here, and the base would be the 3, so it'd be the 3 centimeters times the 4 centimeters divided by 2, and then timesing it by 2. So here, 3 times 4 would be 12, and then 12 times 2 would be 6, so the area of a single triangle is 6 centimeters squared, but then I'm going to double it, and I get 12 centimeters squared. Okay? Some of you might be saying, Ms. Keats, we got the 12 and then we divide it by 2 and then we times it by 2 and it could just cancel out. And that's exactly what happened, right? We've talked about this before with triangles. If you take 2 identical triangles and you arrange them in a certain way, you can get them to make a rectangle, right? Which would just be length times width or base times height, right? So if you're going to divide by 2 and then multiply by 2, it does in fact cancel out, okay? But either way, the area of our 2 triangles is 12 centimeters squared. Now we can move on to the rectangles. So if we look at the sides, okay, the sides here are the ones kind of on the slant, okay, and they have a length of 6 centimeters, and it's going to be 6 centimeters along the back here, but the height of that slanted triangle, or of that slanted rectangle, sorry, is using the slant height. So you're not using the 4, because that 4 was just the straight up and down height. You're using a slanted height, and that value is 4.27 centimeters. So what I would need to do the area, it is just a rectangle, so length times width or base times height, right? So it's like base times height, and then I'm going to double it because this one is going to be the same as this one over on this side, okay? So because of that, I can then take my base of 6, multiply it by my height there of 4.27, and then once I get that value, I'll double it. So when I multiply those together, I get an answer of 25.62 centimeters squared. And then I double it. And when I do that, I get a value of 51.24 centimeters squared. Okay? So there's my two triangles, there's the two slanted rectangles, and now I have a rectangle along the bottom, okay? So in this rectangle along the bottom, those dimensions that I've just traced are a length of 6 centimeters and a width of 3 centimeters. So the bottom is just a single rectangle, so no doubling, and it's just 6 times 3, which would give me 18 centimeters squared. Okay, so that would mean now that my total surface area, the amount of wrapping paper I need to cover that little Toblerone bar, is going to equal the 12 plus the 51.24 plus the 18. And when I add all that up together, I get 81.24 centimeters squared. So that's my total surface area for that particular rectangular prism, right? And like I said, there is no formula for that. You could try and do it all on one big line if you'd like, kind of saying, okay, this is the section for the triangles, and then these are the side rectangles, and then this is the bottom. Some people find that too confusing because they don't know what's what, but instead if you kind of label it and organize your stuff, it puts it in the right spots and you know what you're talking about, right? Or if you needed to subtract something for some reason in like a part B of the question, you know exactly where to find it. All right, so that's the triangular prism question. And again, the answers are here in the slides as well. Okay, all right, so our third and final example here. So a standard die, or if you're talking about more than one dice, okay, is the shape of a cube. And suppose we're going to be making our own set of large dice out of cardboard for a giant Yahtzee game. You want each dice to have an edge length of 14 inches, and you need 5 dice to play Yahtzee. You will make the dice by creating a flat net and then folding it together. So think about kind of like putting together like a moving box, right? It comes as like one big flat thing, and you fold it all together, kind of. Okay, so in this case, we're just taking the cardboard, laying it out as the net, and then folding it up and like taping it together. Okay, how much cardboard do we need? And it's asking how many square feet of cardboard will we need to create all 5 dice. All right, so let's look at that one. So what we're doing is we're creating a cube. So we just kind of draw a diagram here. Okay, now with the cube, all side lengths are equal, right? And each one of those has an edge length of 14 inches. Okay. So, to calculate the surface area here, since each edge length is the same and each face is a square, you really just need to calculate the area of one square and then multiply it by 6. Okay? And that's where the formula is going to come from here, right? So our formula is our easiest way of doing this one, where the surface area of a cube is equal to 6 times the side length squared. Right, because remember the area of a square was the side length times itself, right? Side times side, because they're both the same side lengths, right? So just side length squared and then multiply by 6 because there's 6 faces on a cube. Okay, so in this case, our surface area of our dice is 6 times 14 inches squared. So again, use your exponent laws, do your 14 inches squared. 14 times 14, or 14 squared, is 196. Okay, and then you just multiply that area by 6, and you get a value of 1,176 square inches. Okay, so there's our surface area. However, the question asked for how many square feet of cardboard are we going to need. So this kind of brings back another lesson we did before on conversions with areas, right? So remember, our conversion of those 12 inches in a foot, that works for just a flat length. This is an area. So because an area is 2-dimensional, what we need to do is multiply by our conversion factor twice. Okay, so I would take my 1176 inches squared, multiply it by the 1 foot divided by 12 inches once, and again twice, right? Because it's You're trying to cancel out inches squared. You need 2 inches to cancel, right? Inches and inches. That'll go, and you'll be left with an answer in feet squared. So it's 1176 times 1 divided by 12 times 1 divided by 12, and you get an answer of 40.8 feet squared. Okay, and that's how much cardboard we would need to make, oh, actually, that's how much cardboard we would need to only make 1 dice. So I actually have done this incorrectly because I was looking at the wrong spot. So actually, if we go back, that was only for 1 dice. We need to first multiply this by 5 to get 5 dice, right? So to do 5, we would do 1176 square inches multiplied by 5. That gives us 5880 square inches. Right? So that's the total inches squared that we need, and that's the value that we multiply by our conversion factor twice. Okay, and then when we do that, we get the answer of 40.8. Okay, I was just looking at the wrong part on my sheet. Kind of skipped a step there. All right, but you would get 40.8 square feet of cardboard is needed to make those 5 die. Okay? All right, so, all right, and again, that's where you're seeing that, right? So find the area, multiply by 5, then do the conversion, and there's where you're at, okay? So there's your examples on how you would find the surface area of a rectangular prism, a triangular prism, and a cube. And I will also be providing you, like I said here, with a set of practice questions with answers so you can kind of try some on your own and check your answers and see if what you're doing is correct. Okay, and then our next lesson will be on looking at finding the surface area of cones and cylinders. Right, and that's the last lesson for Chapter 3, and then we start looking at a chapter project. Okay? Again, if anything is confusing, it's not making sense, you need help with something, please email me. I will gladly get back to you. If you need to schedule a Google Meet for me to kind of explain something to you one-on-one on a whiteboard, I will gladly do that as well. Just let me know. Okay?